So in the previous video, what we started to think about was how to accurately time our stimuli. There's a couple of ways that we can do this. Oftentimes, we want to get really exquisite control, often in the millisecond precision for the duration of our stimuli. And in this video, we'll go through a couple of ways that we can do that. So here we have just the standard opening. We've got our window object, we've got our stimulus. In this case, it's going to be like an orangey, yellowy colored circle with three sides, and so it's going to be a triangle. And what we do is we draw that stimulus to the window and then we flip that window onto the screen. So the first way that we could time the duration of this stimulus, which is rather crude, okay, is to use core.wait. So if you remember, if we go to the Psychopy documentation, we've got the basic clock functions here. If we go down to get time, oh sorry, up, where are we? Get time, wait. Okay, so this will wait for a given time period. So, and what does it take? It takes seconds. So if we go back to our program here, if we then core.wait, and let's say we wanted to present it for, say, 3 seconds, it's going to do that. So it will draw the stimulus to the window, flip the window onto the screen, and then it will wait for that 3 seconds, and then it will turn off. So let's have a look. It's going to present it 1, 2, 3, off, and there we go. We've essentially controlled the duration of our stimuli. But this is really rather crude, and it doesn't allow us to change the stimulus parameters during the presentation. So in some cases we want to change, for instance, the radius. So we want an expanding disk, as we did in a lot of the videos leading up to where we are now in this list. So core.wait, and the other thing that we might want to ask ourselves is this a blocking? Is this a blocking function? For instance, does it block the execution of other parts of the program? So we do this, we then go onto this line, and then we do this line, and then it's going to not go onto the next line until this line has been executed. We're not going into multi-threading or any of that sort of stuff here, threads, in this set of videos. There are ways around this, but this function basically says, no, I'm not going to do anything more until I've completed this line of code. So one way we can do it is core.wait. The other way that we can do it, if you remember from the previous video, is we can get a handle on the screen refresh rate. Because remember, we used this RunTimeInfo. This presented 60 back-to-back win flips, and it calculated the refresh rate of the monitor or the hardware that we're using for that particular experiment. So let's see what we get. We will turn off the stimulus drawing. So the idea here is every day before you run that experiment, you probe the refresh rate of the monitor and then you lock in that value. Or if you've got a really good quality computer and monitor setup, of which this is not one, this is quite an old laptop, you can do it right at the start and you go, right, this is the refresh rate. So in this case, it takes 18.94 milliseconds for each win flip. And so therefore, when we do 1 divided by the screen interflip interval in seconds, we come up to 52.8. So it's actually quite low. Should be sitting at about 60, but I've got OBS running. Windows is probably doing some stuff in the background as well. For the sake of this video, this should be fine. So we know now that each frame, each refresh will take, in this case, 18.94 milliseconds. So if we wanted to present our stimulus for 1 second, it will be essentially 1000 milliseconds divided by each interflip interval. And that will give us the number of frames that we want to present that stimulus for. And then we just loop over, or create a loop over that number of frames. That's our stimulus. And this has many hidden advantages as well. And we'll go through some of those. So what are we going to do? Let's populate some stimulus parameters. Let's say one of the things that we often want to do is we want to present our stimulus multiple times. So let's say we want to present it 10 times in total. And then what we need to do is we need to think about, well, what's the duration of the stimulus that we want to present it for? So duration of stim, Let's say we want it to go for 500 milliseconds. So this is in milliseconds. And let's say we want to present our stimulus for 500 milliseconds, and we want to present it every second. So the frequency of the stimulus presentations will be 1 a second, and for each second, only the first half is going to be the stimulus. We'll present the stimulus. So time off is going to be 1 divided 1000 minus the stim. Because we're doing it every second, time off is going to be 1 second, take the time on. So if we make the duration stimulus now 250 milliseconds, it's going to add on a bit of time at the end for the time off. So this is one way that we can accurately time the on and the off components and the frequency with which we present the stimulus. We've got a duration here, duration of stimulus. We need to convert this into how many frames will this be? So num frames stim will be, well, it'll be the duration of stim divided by the screen IFI. Let's print this out. The stim will be presented for let's see what we get. So in this program, every time we run the program, it's going to do a refresh test. When you do your experiment, you only probably want to do it once at the start of that day. Or if you've got a really good quality hardware system, you can probably do it once. So here we go. Each frame took 16.77 milliseconds on average, so therefore we've got a frame rate of 59.63. And so therefore the stimulus will be presented for 29.8151460. This doesn't make sense. You can't have a fractional frame. So what we're going to do in this particular example is we will just force it into an integer. And so therefore we will get very, very slight timing errors here. So the duration of, say, a frame, which would be 16 milliseconds, and that can be quite severe in many of the hardcore electrophysiology experiments. So we can talk about ways of getting more accuracy. In this case, we're just going to force it into an integer. So here, we know now that we've got a duration. We're converting a duration into the number of frames. So here we go, 16.66 milliseconds per frame. And so if we want half a second, we want half the frames per second, and so it will present for 30 frames. So here we go. We know the number of frames that we want to present our stimulus for. But remember, we've got this time off. So we also need to calculate for how many frames we don't present the stimulus, or we turn the stimulus off for in this particular experiment. So we say number of frames off, okay? Now, what we can do is we could do this calculation based on the time off. So time off divided by number of frames stim. But the other way that we can do it, which reduces the number of calculations, so we'll turn this off, is because we know that we have got a handle on the number of frames per second, what we can do is we can just say, okay, and we want to present it every second, we know that the screen FPS, which is the number of frames per second, minus the number of frames of the stimulus will give us the bit that's left over. So in total, we've got 60, in this case, we've got 60, and we've got 30 taken up by the stimulus, and so therefore 60 minus 30 will give us the bit that's left over. And so even if we drop the stimulus duration down to, say, 250 milliseconds, right, we still have the total for each second minus the amount that we present that stimulus for will give us the bit left over. So we don't need to do this calculation, we just need to do this calculation here. Again, we're going to get a fractional number of frames for off, and we'll just print, okay, the off frames will be, now I know that there are going to be errors in this, I'm just giving you the concepts here. You will need to use the rounding function, the maths round, to get, or print, to get better accuracy. I'm just presenting the ideas here. So in total, we have got, let's see how many it comes back with. So total in 1 second is 51 frames. So we want 500 milliseconds, or half a second is going to be half of this value here. So it's rounded it down to 25. And then the number of off frames is going to be 26. All right. So as you can see, my screen refresh rate is jumping around quite a fair bit. Again, this is not a concern because I don't use this computer for my experiments. So now we've got the number of frames that we're going to present a stimulus for. And so therefore, what we can do is now write our program. So how do we now control? We want to present our stimulus for 500 milliseconds, off for 500 milliseconds, and we want to present this 10 times in total. We can control that based on user input. So how do we make this? So we'll use some for loops. So for I in range, be the range num stim. So this will loop over the number of stimuli that we want to present. And now we've done that, we want to loop over for j in range. So here we want to present it a certain number of times. So that is going to be the number of frames stim. Okay, so we'll do something here. We'll just pass over that for now. So this bit is going to be the stimulus presentation time. And then this next bit is going to be the off time. So no stimulus. So for j in range num frames off. Okay, and then what we'll do is we'll say, oops, we'll just put just a print statement. Current stimulus number is so it will present to the output the current stimulus presentation, and then so this is the general scheme of things. What do we want to do at the start? Well, we want to present our stimulus in this first bit. So we've got our stimulus here. What's it called? It's called stim.draw. We draw it to the window and then win0.flip. So this should work. So it will do this loop here, go around and around and around for the numbers of frames we're going to present the stimulus for. This is good. And then we want it off. So how do we turn the stimulus off? Well, we could create a whole new window and then present a whole new window. Or the other thing that we could do is we could essentially turn the stimulus off by in this case, stim.radius equals 0. We just set the radius to 0. And then stim.draw and then win0.flip. So here what we're doing is we set the radius to 0, we then draw the stimulus, and then we flip it for the numbers of frames that it's off for, and then we go right back up to this top, we print the current stimulus, and then we go through again. Let's see what we get out of this. So it should do it 10 times, once per second, with the first bit being the stimulus, and the second half being we turn the stimulus off. So it's doing its background check, its refresh time. So there it is. So, oh, hang on. We're still going through the current stimulus. Right, so it's done it 10 times, because remember, Python is 0th counting. The first one worked, but then the second one, it turned off for some reason. Why is that? Well, if you remember, we initialized our stimulus with a 100 pixel radius. And so the first time we presented it, it's called up the parameters that we've created before, we initialized before. So it worked fine. But then when we went to the first time we created the off time, when we set the radius to 0, it's now updated the behind the scenes parameters to 0 radius. So what we need to do is we need to just make sure that we set the radius back to 100 for each time we present that stimulus, because the radius is just going to go 100 and then 0, back to 100, back to 0, back to 100, back to 0. So let's see if that's worked. So it's going to do its refresh test. There we go. And if we have a look here, it seems to be pretty much locked in. Bonk, bop, bop. Okay, which is really quite exciting. Now, we've got another advantage here, just quickly. Because we're drawing the stimulus within inside this for loop and inside this other for loop, let's now change other parameters. So we could do something like stim.edges, okay, equals, let's say I plus 1. So what's going to happen is the first time that this is called, it's going to be 1 plus 1. So it's going to set stim edges to 2, which is going to be a line. And then the next time it comes around, it's then going to go to 3. So it's going to be a triangle, and then a square, and then a pentagon, and then a hexagon. So you see, we've got really, really good control over the stimulus parameters as well as the stimulus timing by thinking about it in terms of the numbers of frames. We can also use these control loops and the for loops to set the position, and we can make it move around. So there you go, triangle, square, pentagon, hexagon, heptagon, octagon, nonagon, decagon. Yes. Okay. So there we go. We get accurate control of the timing of our stimulus by thinking about it in terms of frames. And we then control for the stimulus hardware setup that we have by probing the RunTimeInfo, which does 60 flips back to back. It returns the average refresh time. And from there, we calculate, hey, it's going to take this many frames to present the stimulus. Now, we do have some small little lurking errors here because we are just converting things into integers. And so you would need to calculate yourself or figure out for yourself, do I need to round up or round down for a certain duration? Okay, and you can use the math modules for that, I believe. We won't do that. You've got the point here. Good luck. And we'll leave this one here.